Okay, let's talk about the time value of money. And this really is an important topic in finance. And you will soon come to realize how this is kind of the backbone when it comes to calculating the NPV, DCF, and all of that fancy sounding stuff. So let's say I give you $100 today, and you decide to deposit that money in a bank that will pay you 15% in interest every year. So if you deposit this $100 today, let's call it year zero, what will be its value 1 year from now in the future? That is, what is going to be its value in year one? Well, I'm sure you have done this a number of times in the past. It's just going to be equal to your initial investment 100 into 1 plus the rate of interest. And the rate of interest in this case is 15%. So it's just going to be 100 into 1 plus 0.15. And that's going to be equal to $115. So $115 is the future value of this $100 1 year from now. Future value is just the value of your money after investing it for a certain number of periods. In this case, the number of periods is just equal to 1. Let's think about the reverse case. Again, you have a bank which pays 15% in interest. You have the same bank, and maybe now you want $115 1 year from now. Maybe you want to buy something that costs $115. So you ask yourself the reverse question: how much money will you have to deposit in the bank today so that you get $115 1 year later? That is, in year one you want $115. So how much money are you going to deposit in the bank in year zero? We call the amount of money that you're investing today to be the present value of investment. In short, PV. And remember how we did the calculation in the last case. We deposited some money, and in this case, we are calling it PV, and we multiplied it with 1 plus R, and then we got the future value. Now we are given this future value to be equal to $115. We know R, so we can easily calculate the amount of money that we are supposed to be depositing today so that we get $115 1 year from now. So your PV just comes out to be 115 divided by 1 plus R, which is equal to 115. 1 plus R is 0.415 again, and that's equal to $100. That is the present value of investment, exactly what we expected it to be. Hopefully you're getting around the idea now. Till now we have only calculated for one period investments. Now let's take a look at how to calculate these values for multiple periods, and then from there we'll be able to kind of infer the general formula for calculating the present and future values. We'll be working with the same example. What if you deposit this $100 again in the same bank, but now you keep the money in the bank for 3 years? What will be its value 3 years from now? Well, you have $100 in year zero. Now we are asking what will be its value, future value in year three. And do remember, your rate of interest is again 15%. Well, you deposit $100 today, and in year one, you'll get 100 into 1 plus 0.15, as we did in the last case. So that is equal to $115. This is year one. In year two, in your second year, you take this $115 and you multiply it by 1 plus 0.15. Because remember, we are getting that 15% interest on what we already have in the bank. And at this moment, we have $115. So we get 15% interest on top of that. So you have 115 into 1 plus 0.15, which is equal to, let me just quickly input this into the calculator, $132.25. Similarly, in year three, you'll take this 132.25 and you'll multiply this with 1 plus 0.15, which is somewhere close to $152. So that is the future value of $100 at 15% interest after 3 years. Now let's try to generalize this with the help of a formula. Notice $152 is just 100 into 1.15 into 1.15 into 1.15, or in power form it is 100 into 1.15 to the power 3. That is your initial investment 100 multiplied by 1 plus r raised to the power number of periods, because we had 3 periods in our example and over here it is raised by power 3. So T stands for number of periods, and let's quickly write down the formula that we are inferring from over here. So the future value is equal to your initial investment, and I'm calling this initial investment C0, which stands for cash flow at period 0. Basically the cash flow the value that you're investing in today. You'll understand why I'm calling it a cash flow when we progress further into this chapter, but it's always nice to get acquainted with the terminology. So it's C0 into 1 plus r to the power number of periods, and that is the value of the future value of your investment. Now we have a future value of an investment. From this we can calculate the present value of investment as well, very similar to what we did in the single period case. Over here you will be given the future value, and C0 is what you need to find, because again C0 is the value you are investing in period 0, and that is the present. So that is the present value we need to find, and I'm going to call this C0 PV now, and that becomes a subject. So what is your future value? It's just the money you will be getting after you invest it for T number of periods. So I'm going to call this future value CT, which is the cash flow that you're getting in your final period or period T. So your formula for present value becomes PV is equal to CT divided by 1 plus R to the power T. And let me quickly box it up, and let me box this up as well. That's a very untidy box out there, but it does the job. Anyway, so if you take a closer look at both of these equations, it's the same stuff. This stuff has been kind of rearranged. Do note that this R that we're talking about, which is the interest rate used to determine the present value of a future cash flow, is called the discount rate. So let me quickly write it down. It's called the discount rate. All right, hope you got around this. In the next video, we'll take a look at Excel formula to calculate the present value, number of periods, and all of that. See you in the next one.